Two-factor ANOVA with replication. On the prior example, we looked at two-factor ANOVA without replication. And that was a two-factor test. We consider it to be a two-factor test. Excel considered it to be a two-factor test. We actually had one factor was like blend X, blend Y, and blend Z of the gasoline. And that was the main factor. But we introduced a second factor by blocking together the automobile. So we actually created this second factor running down the side here. Automobile 1, automobile 2 blocked together. So we kind of created this factor. There's another way that we can look at two-factor with replication. And what that means, when you have a genuine second factor. So let's go back to the original introductory example I gave you about fertilizer. Supposing I'm trying to test the difference between fertilizer 1, fertilizer 2, and fertilizer 3. But now, apart from the 3 fertilizer, I've got 2 different types of potatoes that I'm actually planting. So let's call it potato 1 and potato 2. Now this can actually lead to differences in yields, the amount of potatoes I get at the end of the year, based on one factor, which is fertilizer, and based on the second factor, which is the type of potato I use, the type of potato I plant. So there are 2 factors that can affect your yield. I didn't manufacture the second factor by blocking it. It's just that it is a genuine second factor. And when I have 2 factors, I replicate the example. So I will put fertilizer 1 on potato crop 1, not just one time. I won't do the experiment just one time. I will do it at least a second time. And that's why you say it with replication, because you're going to repeat the experiment at least a second time. You can do it 3 times, 4 times, 5 times, but it's going to be at least a second time. The benefit of doing this test when you repeat it as well is that you get another result other than just looking if the average yield for the different fertilizers is the same or different, the average yield for the different potatoes is the same or different. We get a third result, which is called interaction. So what does interaction mean? Interaction, I'll give you an example of what it could mean here. Let's just suppose that when I put fertilizer 1 on crops, it doubles your yield. And typically, potato type 1 actually gives you triple the yield of the next potato. So in an ideal world where there's no interaction, if I put fertilizer 1 onto this type of potato, this is already going to give me 3 times the regular yield, and the fertilizer will further double that and give me 6 times the regular yield. They just do their own thing independently. Whatever fertilizer 1 finds, it will double. No interaction, giving us 6 times the yield. But if there is interaction, what may happen is that fertilizer 1, instead of doubling the yield, it interacts in a negative way and it actually burns your entire crop and you get no yield. Or it could be, when you put fertilizer 1 onto potato 1, it actually gives you 10 times the yield. So they interact in some strange way that we can't really account for. When that happens, we have to strip out and look at each factor independently. We'd have to look at the fertilizer independently and run a separate test, and also run a separate test for the potatoes. The actual outcome, the output from Excel, will look something like this, as you can see the table in front of you. And now we're going to do an example.